it's Mrs. Pound, and we are starting a new chapter today, chapter 4.1, on forces and motion. The first section in this chapter is on forces. Our objectives today are to compare types of forces, identify the four fundamental forces, and calculate gravitational force. So you should be pretty familiar with forces. There are all kinds of forces taking place around us. We are applying force to things. So force is pretty common around us. The basic definition for a force is it is a push or pull exerted on an object. So I have two puppies here and they are pulling on the rope toy. Now the unit of measurement for force is the Newton, and it equals 1 kilogram times a meter per second squared. We'll see where that unit comes from when we talk about Newton's laws. But what we use to measure force are spring scales here in the background. So we will be using these in class during some labs. Now there are different types of forces. One type of force is a contact force. This requires contact between two objects or substances. That's why I have the two hands touching each other in the background. There is contact, actual physical contact between the two people. One type of contact force is tensile force. This is a force that results from a pull exerted on an object. It causes tension. So when you say that there is tension in a rope, you're talking about tensile force. And so these puppies are using tensile force. They're putting tension in that rope toy. There's also compressional force. This is a force that results from pushing or squeezing an object. So when you make orange juice, not lemon juice, you do the same thing with lemons, but when you make orange juice, you are applying compressional force. You're squeezing it, just like a compressor compresses air. Another contact force is friction. This is a force that resists motion in two objects that are moving against each other. When you're lighting a match, you can feel that friction. You can feel that resistance that provides enough energy for the match to be lit. And then there is shearing force, and I have a picture of scissors here because shearing force is back and forth force, like this, or maybe even like this. And an old word for scissors is shears. So there are also four fundamental forces. These are non-contact forces. The objects do not have to be touching one another. And the first one we should be pretty familiar with is gravity. This is an attractive force between two objects with mass. And an example is a ball falls to the ground, just like these skydivers are falling to the ground. They are attracted to the earth, but there's nothing touching them. They're not touching the earth, and yet they are still attracted to it. Now, interesting thing about gravity is the farther you get away, the less the attraction. The closer you are, the greater the attraction. And there is actually gravity between you and your computer or whatever device you're using to watch this video right now. But gravity is a very weak force, and because the mass is very low, the gravitational force is not great enough for your device to fly at you. Gravity, in fact, is the weakest force in nature. Now, an equation we're going to be using is force equals mass times acceleration due to gravity. F equals m times g, where g, the acceleration due to gravity, is 9.8 meters per second squared. We will be working with this equation in class, but I wanted you to have it in your notes. The second fundamental force is electromagnetic force. This determines the ways in which electrically charged particles interact with each other and with magnetic fields. Electricity and magnetism are very closely related, so they are lumped together as one force. And an example is that the electromagnetic forces hold electrons in orbit around a positively charged nucleus. Now, a force you're probably not familiar with, maybe this is the first time you've ever heard of it, but another one of those fundamental non-contact forces is the strong nuclear force. This is what holds protons and neutrons inside the nucleus of an atom. Now remember, protons have a positive charge. So positive charges don't like to stay together. They like to repel. So protons should fly apart, but they don't. And what's holding them together is this strong nuclear force. So an example is protons do not repel each other, but stay together in the nucleus. Now, this strong nuclear force is really a mystery to scientists as well. They really do not know how this works. And so I think this is just one of those mysteries of the creation of God. And there is a verse in the Bible that talks about the fact that God holds everything together in his hand. Okay, Jesus holds everything together in his hand. And so I just have this picture of Jesus holding together the nucleus of the atom since he created them. And number 4 is the weak nuclear force. Again, probably haven't heard of this. It is responsible for certain types of radioactivity. And an example is this force prompts the nuclear fusion reaction that fuels the sun. So nuclear fusion is when nuclei come together. And again, that should just not happen because of the fact that the nucleus of each atom is positively charged, but the weak nuclear force causes this to happen. And they call it weak nuclear force because it's not as strong as the strong nuclear force. So our objectives for this video were to compare types of forces, to identify the 4 fundamental forces, and to calculate gravitational force. We'll be doing more of that calculation in class. So don't forget your 5 questions, and I'll be back with more on forces and motion.